In this video, we're going to go through a review of Pythagoras' theorem. So we're going to go fairly quickly through it. So if you're brand new to this, perhaps this is not the best video for you. Just a reminder about what Pythagoras' theorem is that in a 90-degree right-angled triangle, the following rule applies. And you may be used to seeing it with h squared for the hypotenuse side, or you might see it with c squared, and that the other side is the a squared plus b squared. So, working with an unknown hypotenuse to start with, we'll work with the rule in the usual form, as in where the h is on the left-hand side of the equation. And here's our example here. We need to find the length of the hypotenuse x. You might like to write on labelling it h and the other sides a and b. It doesn't matter which sides you label a and b, they can be opposite. Then let's write out the formula, putting in our values there. So instead of h, we're putting in x squared, making that equal to a squared, which is 4 squared, plus b squared, which is 7 squared. Working all of that out, keeping the x squared on the left-hand side, 4 squared is 16, 7 squared is 49. Adding those together, you get 65. But x squared, we have to undo that, and the opposite of a square is doing the square root. I'll show this plus or minus the first time round, because when you do the inverse of a square, you do the square root. You do technically need to consider that there's a positive and a negative version. However, because these are measurement questions, the hypotenuse is the length, we can say that it's the positive version. You don't have to write the plus there, and you might see written there sometimes as x is, well, that's a greater than sign, is greater than 0. So that considers that case. Hopefully that's a refresher. Let's do a couple more. This time, what about when you know the hypotenuse but you don't know one of the other sides? So the formula we're going to use here could already be rearranged. So we've still got h for your hypotenuse, and then you've got sides a and b. My advice, the side that you don't know, so this x side or whatever letter variable it is, make that the a side. It's just going to help with your rearranging. So let's substitute these numbers in. We're using this formula here. As you can see, it's a rearranged version. A squared, instead of an a, we've got an x, equal to the hypotenuse, so that's 7 squared, subtract the side b, 6 squared. Now let's work these out. It's good to sort of line up your equals and keep writing x squared on the left. So what have we got there? We've got 49 minus 36, which gives us 13. And then we undo the square, which means we do the square root. And so we have the square root of 13. So finding the length of the third side, what I should have done on the previous one and here too, we need units. So the side is how long? Root 13. Now that is a number. Don't be scared by the fact that it's got a sign there, and it's in centimetres. So make sure you put the units each time. And go by your teacher as to whether or not they'd like to see the plus or the minus and the x is greater than 0 step. So what about when we have an unknown hypotenuse, but this time round you can see that there's a square root in one of the sides. The little guy here with his reminder, remember that when you square a square root, it just ends up with the number that was under the square root. Let's put that into practice. You might like to label the sides. It doesn't matter which is a and b. And then let's use Pythagoras' theorem. So we've got h squared, which is the x squared, is equal to the others squared. So what I'd love to see you write is 17, but you have to square it. Do use brackets, please. Plus the other side squared. Now, what does that work out to be? The 3 squared is 9. That's easy enough. And the root 17 squared just leaves you with that 17 number. So do remember that. And keep working this out. 17 plus 9 gives us 26. Undoing the square gives us the square root of 26. So find x. X is 26 centimetres. We can just add the units on at the end there. Another one, this time where the hypotenuse, we're still solving for the hypotenuse, but it's got an x in it as well. And as the little tip person says here, the use of brackets here is essential. Let's go through it. Label your sides. Hypotenuse, a and b. Doesn't matter which a and b are, it will still work out the same. Now, hypotenuse squared, that 3x, I'm going to do one off to the side. It is not this. That is wrong. We need to have brackets because we need to square the number 3 as well. Let's write the whole thing out though. X squared plus 4 squared. Now, you apply the square. If you remember your indices laws, they apply to both things in that bracket. So we have 9x squared there, not just 3x squared. And x squared plus 16 here. Now we need to solve for x, so you need some algebra skills here. You're welcome to do this all in one step. If your algebra's pretty good, you're rearranging, but I just wanted to show you in case you need a refresher. So we're collecting like terms. So you subtract x squared off both sides, which leaves us with 8x squared on the left and 16 on the right. Then we need to divide through by 8. I'm just going to jump straight to that answer. 16 divided by 8 is 2. And now that kind of looks like the other ones we've had, where we undo the square root, and square root the right-hand side, find the value of x. What's the units? This time round it's in meters. So there's taking you through some examples of Pythagoras, a bit of a review there, and there's some textbook questions to do if you're part of Year 11 General. Thank you.